Hello dear children, in today's class we are going to discuss the numericals based on sound. Just we are not going to solve all the numericals. So previously already we had uploaded the numericals based on the sound chapter, but especially in this session we are going to see the what are the 5 models which we have from the sound chapter. Only 5 models we have, children. So if you can practice these 5 models, yes, you are able to solve the numericals which are going to be given based on the sound chapter. You should be very careful. So it's a 5 chapters here. So in a first model, in a first model, just the person will be standing in between the 2 cliffs and he can hear the 2 echoes. The time interval will be given. Then you are asked to calculate the distance between the 2 cliffs. First model. In the second model, same concept, but time will be given 2 seconds later or 3 seconds later. So a little bit difference will be there. Okay, fine. In the third model, initially the person is standing in front of a cliff. He makes some sound. He can hear some that echo in some time. Then the person may move little bit forward or little bit backward. Both might be. He may go little bit forward or little bit backward. Then again he makes some sound. He can hear echo once again. So in that situation also you are asked to calculate. We are asked to calculate the distance between the cliff and the initial position, or a distance between the cliff and the final position. Okay, fine. And the fourth model. So 2 persons will be standing back to back. Okay, now one person near to the cliff, one person behind the one more person. So the person who is standing between the just in front of the cliff makes sound. Let us say person A makes some sound. Then the person B who is standing behind the person A may hear 2 sounds, not echoes, 2 sounds. In that case, how we are going to calculate the distance and the speed? Fifth one, yes, this is what actually is going to be fifth one. So one simple pendulum is, so in general, whenever we are solving numericals based on echo, the time taken will be given, the time in which echo is heard. But in a fifth model, time is not given, indirectly it is given. So in terms of time period is given. So how we are going to use this time period to calculate the distance between the person and the cliff? So these are the 5 models which we are going to solve, so that children, again I am telling you, you are able to solve the numericals. And one more thing very important. So whenever a numerical is shown on the screen, my advice is that yes, pause the video, try the numerical, try to comment your answer. Of course, it's your wish. You may or you may not. It is not compulsory. We are not forcing any student to comment. But if you can comment, just I'll go through it. A kind of satisfaction I have. Yes, my students who are watching, they are practicing the numerical. I don't want my students to copy the solution what is explained in the board. No, I don't want just my students to copy. I want my students to practice the numericals. That's what, whenever a numerical is shown, pause the video, try it. So these are the 5 models. Get ready with a pen and a notebook. Let us have the good practice so that we'll get what we can say confident to solve all the numericals based on sound. Okay, let us start. Let us see the first numerical, dear children, and the numerical is shown on the screen. So my advice is that yes, once pause the video, try the numerical, try to comment your answer. Even you can cross check with the solution which is going to be taught. Okay, fine. So as per the numerical, children, it is given that, let us say first number. Hope you are able to see. Okay, so let us say a person is standing in between 2 cliffs. In between 2 cliffs, let us say. Okay, let me draw 2 cliffs. Might be obstacles. Okay, now let me draw like this. So this is first cliff, let us say, and here is one more cliff. So here is, let us say, he is standing and fires a gun or makes some sound, and he can hear the echo. How many echoes he can hear? Yes, 2 he can hear. One is from, let us say, cliff A, one more is from cliff B. So as per the question, he can hear the first echo in 2 seconds, second echo in 4 seconds. With that, it's very clear that he is standing near to one cliff, bit far from other cliff. So let us say that here the time taken, case here with this cliff A, let us say time taken is 2 seconds, and he is standing, let us say, distance d1. Okay, now here the time taken is given 4 seconds. So let us say this distance is d2. Fine. Now here the speed of the sound is given. How much is given? 320 meter per second. Okay, Speed of the sound is given 320 meter per second. Now they are asking us to find the distance between the two cliffs. Here we have two cases. So individually we have to calculate d1, then d2. If you can add these two, you will get the total distance between the cliffs. Fine. Okay. For this, the main formula is V is equal to 2d by t. From this, let us make a d is equal to Vt by 2. So now this is a formula which we are going to use. Now first, let us apply for cliff A. For cliff A, time is how much, children? Yes, time is 2 seconds. Anyhow, speed is 320 meter per second. Now let us substitute in this. Then d1 is equal to 320 into time is 2 seconds by 2. 2 gets cancelled. This will be 320 meters, means the distance between the person and cliff A is 320. Now let us calculate for cliff B. So here the time taken is 4 seconds and yes, speed is 320 meter per second. Now let us calculate the distance between the cliff B to the person. So let us say the distance is d2. So this is 320 into 4 by 2. 2 ones are 2 twos are. 2 into 320 is how much it is? 640 meters. These are distance d2. Now they are asking us to calculate the total distance, right? So total distance is d is equal to d1 plus d2. So this will be 320 plus 640. This will be 960 meters. So this is the total distance between the two cliffs. Okay, children, just copy that. Yeah. In the second model, if you can just see the numerical shown on the screen. Okay. So just it is said that yes, a person is standing between the two cliffs, makes sound, and he can hear the two echoes. It is given that he can hear first echo in 4 seconds, 4 seconds, second echo 2 seconds later. Very important, very important. So this word 2 seconds later, children, this later word is a hint to us. If you won't think about this later word, then complete numeric will go wrong. 2 seconds later means what? First he is using 4 seconds, later 2 seconds. Means what is the total time taken to hear the second echo? 4 plus 2, 6 seconds. This is a point where we should understand. Okay. So now the time taken is 2 seconds later means what? First 4 seconds plus later 2 seconds. So this 2. The total is 6 seconds. That's it. Once you know this, you can get that. Now the solution is same. Come on, children. Do the same manner. Calculate d1, d2. Come on. Pause the video. Try to solve and comment your answer. Okay, fine. Okay, let me just meanwhile. Okay. So d1 is equal to, so v is 320. Time is 4 seconds by 2. 2 ones are 2 twos are. This will be 640 meters. In a second case, d2 is equal to 320. Children, 2 seconds later means for this time you should add. That is, sorry, not plus, into 6 by 2. 2 ones are 2 threes are. This is 960 meters. Then the total distance is how much? 640 plus 960. So this will be 1600 meters. 1600 meters. Children, a small difference is there between first model and second model. In second model, what? 2 seconds later. Means whenever you can see the term called later, then you should add the time to the time taken to hear the first echo. Okay, just copy this. Yeah, now let us see the third model, children. So as per the third numerical, yes, you can see on the screen as usual. So here is, let us say here is a cliff. Okay, and the person is standing. Let us say initially the person is standing at some distance. It is not given. Let us say distance d. Here he makes some sound so that he can hear an echo in some 3 seconds. What is given as per the question? So this is yes, 3 seconds. So let us say initially it is a 3 seconds. Okay, 3 seconds. This is the first situation given, children. Speed is not given at all. First situation. So first let us apply the concept to whatever we know the first situation. Okay, so what we know? We know that v is equal to 2d by t. And children, don't forget that here velocity is not given. In this question, velocity is not given. That even we have to calculate the speed of the sound, the velocity of the sound in air also. Okay, now here if you can apply, v is equal to, this is 2d by 3. That's it, equation 1. That's it, we have this much information only. Now, the person is moving towards a cliff by 82.5 meters. Person is moving, how much? 82.5 meters towards the cliff. Again he fires a gun. Then he can hear echo in a 2.5 seconds. 2.5 seconds. Now what is this distance in this case now? In this case it is total distance minus 82.5. So this is going to be d minus 82.5 meters. Now this is a second case. Now let us apply the same concept to the second case. Let us say case 1, case 2. So v is equal to 2 into 82.5, sorry, d minus, excuse me, it is d minus 82.5 by, time taken is how much? 2.5 seconds, equation 2. Now let us equate this equation 1 and equation 2. As LHS are equal, RHS can be equated, right? Okay, so from 1 and 2, what we can write here? 2d by 3 is equal to 2 into d minus 82.5 by 2.5. 2 gets cancelled. Do the cross multiplication. D into 2.5, it will be 2.5 times d, and this with this 3 you have to multiply this entire this one. So d into 3, this is 3d minus, so 82.5 into 3. So it is 247.5. 247.5. Now transpose this, get this side, and this has to be this side. So then 3d minus 2.5d is equal to 247.5. So this will 3d minus 2.5 is a 0.5d. 0.5d means what? D by 2. Children, 0.5 can be written as 1 by 2. So 1 by 2 into d is equal to 247.5. Now this 2 will go this side. So then it multiplies. D is equal to 247.5 into 2. So this d is going to be 0.594. So 495 meters. So they asked to find the distance between the cliff and initial distance, initial position. So this one will be 495. If they will ask what is the distance between the cliff and the new position, then what you should do? 495 minus 82.5. So that will be the distance between the cliff and the new position. Now this first part is over. In the second part, they asked us to even calculate the speed of the sound. So this, what is the d value which we got? You can substitute either in equation 1 or equation 2. So let us do here. Let us take a equation 1. From this, v is equal to 2 into d value, how much we got? 495 by 3. 3 ones, 3 ones are 3 6 are 3 5 are. So if you can calculate, v is equal to 0 3 3. So it's a 330 meter per second. This is a third model where the person initially standing and makes some sound, okay na, and he can move little bit forward, and you know, question can be given like this. It is not always the person should move towards the cliff. The person may go little bit far away from the cliff also. Same concept. But in that case, here d minus we got. In that case, d plus. For example, the same numerical, same data. If the person will move a little bit back, then d plus 82.5 meters. And the procedure is same. Everything is same only. Children, just concept is important. Don't try to by heart. Because these three numericals purely based on the v is equal to 2d by t only. But the way how we are solving little bit differ. Okay, copy it. Now let us try to solve this fourth numerical. Yeah, let us see this fourth model, children. So here you will get surprised. It's a very, one of my favorite numericals, and I'll tell you where many students go wrong. But after seeing, after watching this video, especially after practicing this numerical, you people, that is our students, can never go wrong. Okay, fine. So as per the question, I mean say fourth model. Okay, now here person A is standing at a distance x from the cliff, and one more person, let us say person B, is standing y distance from the cliff. Y distance from the cliff. Then what is the distance between A and B? Y minus x. So this distance will be very important. Understand this, very important, children. This is y minus x. This distance will be y minus x. Now thing is that here the person A fires a gun or makes some sound. Okay, fires a gun. Then here in a question they are talking about the person B. Okay, and it said that person B can hear two sounds. Children, two sounds. You have to handle in the two sounds because it is not two echoes. You may get one doubt, sir, what makes the difference? Yes, little bit difference is there. With that, entire solution will be changed. Okay. He can hear two sounds. First sound he can hear, as per the question, is it 2 seconds? Yeah, 2 seconds. Whereas second sound he can hear, 3 seconds. 3 seconds. Then they are asking us to find the x value and y value. Okay, fine. Now you may get one doubt, sir. Let us take a v is equal to d by t and d is equal, let us calculate. No, it is not that here. Yes, here echo also is involved, but you can't use v is equal to d by t. Then you may get one doubt, sir. As you are saying that echo concept is involved, why can't we use v is equal to d by t? Let me tell you, children. We can use this formula v is equal to d by t only the sound going towards distance d again should cover the same distance. When it is a d and d, then only you can use this concept. But this concept is not involved here. Echo only, but not this concept. Let me tell you, let me give you detail. Okay, the two cases are there here. First, when the person makes sound, children, one sound will go towards B directly. So this is direct sound. Try to understand. This is a case one. Try to understand. Very, very important. First, let us do this only. When this person makes sound, one sound will go towards cliff and one more sound will come towards B. So whatever the person B is hearing, first one is a direct sound. Direct sound. So in this case, first case, yes, the time is 2 seconds. Okay. The distance is how much? Y minus x. Y minus x. Here v is equal to d by t. That's it. Here you cannot use v is equal to d by t. Why? Because it is not echo first of all. The person is hearing a direct sound. So we know that speed is equal to distance by time. So v is equal to d by t. From this, d is equal to vt. Now substitute here. D is what? Y minus x. Is v given? Is v given? Let me check. Yes, 320 is given. 320 into time is how much? 2. So y minus x is equal to 640 meters. Equation 1. Okay. Now, some of you might think, sir, at least chalo, let us use now v is equal to d by t. Still we can't use. Yes. Yeah, you may get on doubt, sir. Why can't we use? Of course. Now the one more sound from here, it will go towards the cliff, get reflected. I mean, echo will take place. It will come again here to the person B. Echo only. But is this sound traveling like a what we can original sound, reflected sound traveling same distance? No. Look at here. From here to here, it is x distance. Okay. X distance. Again, from cliff to person B, it is traveling y distance. This y distance. So, forward it is x, backward is y. Both are not equal. Both are not same. Okay, na? So it is x, y. Now the total distance traveled is how much? X plus y. X plus y. Here you cannot take a 2D. So the distance traveled is x plus y, or you can add y plus x, anything is okay. Fine. Now same concept, v is equal to d by t. So here d is equal to v into t. So d is what? Y plus x, v is 320. In a second case, the sound is going towards the cliff, coming back to person B. In that case, the time taken is given, I think it is given 3 seconds. It is 3. So this will be y plus x is equal to 0, 6, 9. Now it is the equation 2. So here we have two equations. So let us solve these two equations. So y plus x is equal to 960, y minus x is equal to 640. So x cancel, it is 2y is equal to, so this is 1600. So y is equal to 800 meters. Y is equal, so person B is standing 800 meters from cliff. Now this value you can substitute either in equation 1 or equation 2, anything is okay. So from second equation, let us say here, in the place of y, it is 800 plus x is equal to 960. Then x is equal to 960 minus 800, it is 160 meters. So this is x value and y value. Children, nowhere we used v is equal to 2d by t. That's what I said. Echo means it's not always v is equal to 2d by t only. You have to see in a forward direction, in a backward direction. If the sound is covering the same distance, then you can go for v is equal to 2d by t. Otherwise, this forward distance you should add to the backward distance traveled. Okay, just copy this. It's a fourth model. Okay, done. Okay, fine. Yeah. Now let us see the fifth model. So as per this, okay, this numerical is little bit based on the easy numerical, based on the simple pendulum. Okay, na? So I mean to say, one person here is standing now. In one hand he is holding a simple pendulum. Another hand is trying to, fire a gun. Okay, na? Try to understand like this. Okay, na? And see, and the thing is that at the same time he fires a gun, that moment only start oscillating. Both take place at the same time. Here one hint is given. The frequency of the simple pendulum is given. Frequency is equal to, frequency is given 5 hertz. Frequency is given 5 hertz. At time period we know that it is a 1 by frequency. It is 1 by 5. So hence it is a 0.2 seconds for each oscillation. For one oscillation the time taken is 0.2 seconds. Then you may get a wonder, sir, why do we need to calculate the time period? Let me tell you. So for each vibration it takes a 0.2 seconds. But here the condition is given. The person, let us say it is a cliff. Okay, na? It is a cliff. Okay. Now as it is given the question, at the same time it is made to oscillate and he fires a gun. And he can hear the echo. For the time is not given directly. The moment when he can hear the echo, children, during that time, it has completed 8 oscillations. Very, this is a clue. 8 oscillations. So for one oscillation 0.2 seconds. Then for 8 oscillations, yes, that is what our idea. So then it is a n into t. N is the number of oscillations, 8. T is the time period, 0.2. So then the time taken to hear echo is 1.6 seconds. That's it. So this is a point where you should be very careful. Now yes, V is equal to 2d by t. So as per the question, what actually they gave me. So yeah, speed of the sound is given 340 meter per second. They are asking us to calculate the distance. So d is equal to Vt by 2. So V is equal to 340, t is 1.6 by 2. 2 ones are 2, 0.8. This will be 3 fours are 272 meters. That's it. So children, so these are the 5 different models we have. So other than this also, one more question or 2 more question, simple questions can be expected. Have you copied this? Okay, yes, let me tell you. So they may ask a question like this. The person is standing at a 48 meters away from the cliff. Can you hear the echo? Can you hear the echo? Then find the time taken. Yes, use the same concept here. So speed of the sound might be given like 340 meter per second or 320, whatever may be the data given, follow that. So from that, t is equal to 2d by v. So this is 2 into 48 by 340, you can do it. So you will get the time taken. You will get the time taken, then yes, you can calculate. Of course, if it is in the air means 48 meters, obviously you can hear the echo. So, and if they'll ask you to calculate the time, justify your answer. So t is equal to this, you can calculate. Okay, so this t should be greater than or equal to 0.1 second, you should get. If the sound is equal to 0.1 or greater than 0.1 second, yes, you can see that yes, either the minimum time gap between the original sound and the reflex sound should be less than or equal or greater than 0.1 second should be. So these kind of questions also you can expect. Okay, fine. And one more type of numerical will be there. They will give you the ratio of amplitudes. For example, 2:3. They may ask you to calculate find the ratio of the loudness. We know that loudness is proportional to the square of the amplitude. So obviously L1 is to L2 is equal to, this will be 4:9. So these kind of numericals we can expect. Okay, children. So once again, I'm telling you the concept is important. Okay, children, these numericals really enough, really if you have a good practice, these numericals, 99% I give assurance, not 100%. So 99%, yes, you are able to solve the numericals which are going to be given in a board exams based on the sound. So once again, I'm telling you the concept is important. So you have seen, right? So numericals sometimes seems to be same, but little bit difference will, with that entire solution is changed. Okay, children, thank you so much. All the very best.